Hello and welcome to this year's Jump into STEM competition. My name is Mini Malhotra. I am a research staff member at the Oak Ridge National Laboratory. This pre-recorded presentation is meant to discuss one of the three challenges of this year's Jump into STEM competition, titled Resilience for All in the Wake of Disaster. This challenge topic relates to current global issues of increasing catastrophic events and the disproportionate impact of populations around the world. Across the globe, we are experiencing a dramatic rise in the number and increase in the intensity of natural and man-made disruptive events, such as hurricanes, tornadoes, extreme rainfall and floods, earthquakes, fires, explosions, biological and chemical hazards, and so on. The record-setting heat waves in the Pacific Northwest, the drought and wildfires in California, the North American winter storms, and the ongoing global pandemic of COVID-19. These are just a few of the recent examples. These events, natural or man-made, cause damage to the natural environment, such as rivers, oceans, forests, wildlife, the ecosystem, and weather patterns. They cause damage to the built environment and infrastructure that includes our homes, buildings, roads, utility services, and communication networks. They impact our access to potable water, sanitation, food, energy, acceptable air quality, and livable indoor conditions, and thereby pose threat to public health, safety, and well-being. And many result in loss of lives as a direct or indirect consequence. The impact of these disasters is disproportionately large for populations across the world who lack the capacity to withstand and recover from these events. These population groups are not just limited to underdeveloped and developing countries. Even in the United States, communities that are underserved, marginalized, and vulnerable also face a significantly larger challenge in the event of such disruptions. So what does it mean by underserved, marginalized, and vulnerable communities? These communities include those that experience barriers to social, economic, political, and environmental resources due to many factors, some of which are interrelated, such as ethnic or racial discrimination, low socioeconomic status, disadvantaged background, illness, and disability. These communities also include those who live in rural areas or impoverished urban sectors, and often includes individuals who are at a high risk of poor health. This challenge is seeking holistic solutions to improve the resilience of the built environment, making equity a central focus of the proposed solution by strengthening the ability of communities, especially those that are underserved, marginalized, and vulnerable, to adapt, persist, and recover in the event of natural or man-made disruptive events. To make sure that we clearly understand the meaning and scope of the challenge, let's first review the meaning of the keywords here, which includes equity, resilience, built environment, and holistic solution. So, what does equity mean? In social sciences, equity is defined as the quality of being fair or impartial. And what does it mean by being fair or impartial? Giving everyone the exact same resource and expect the same outcome sounds fair, but it is not. When each person has different circumstances, expecting the same outcome is not fair. Equity recognizes that each person has different circumstances and allocates the exact resources needed to reach an equal outcome. The second keyword we want to define is resilience. Resilience is a very broad term and is used in context ranging from ecology, social sciences, and engineering. The overarching definition of this term is the ability of a system to adapt to, persist during, and rapidly recover from a disruptive event. In this illustration, different systems are shown to respond differently to a shock. System D, which is not resilient, starts to decline after the shock and eventually fails. System B and C show different degrees of ability to absorb and recover from the shock. And then there is system A, which adapts to the event, improves its states, and thrives afterwards. In the context of this challenge, the aim is to at least withstand and recover from the disruptive event with minimum impact. The third keyword we want to define is built environment. The built environment includes all of the physical parts of where we live and work, and which support human activities in some manner. These include our homes, buildings of all kinds, building systems, open spaces, parks, the infrastructure including the transportation system as a whole that we use to get from place to place, the distribution system that provide us with water, electricity, natural gas, and the structures for communication network. And lastly, the term holistic solution that the challenge is seeking. In the context of this competition, holistic solution includes technical solution, which could be a design, a product, or a process, as well as non-technical solution to bring the idea from concept to implementation. Non-technical solution could include policy-related solution, for example, regulatory policies or financial incentives, technology deployment solutions such as workforce training and education, economic and commercialization solutions such as different funding mechanisms, or education and outreach program for public awareness. Now that we understand the scope of the challenge, let's review some of the strategies that may help you frame strategies to improve the resilience of building communities and infrastructure. Focus on robustness, resourcefulness, rapid recovery, and redundancy. Robustness is the ability to maintain critical operations and functions when a disruption occurs. For example, designing the structure of buildings to withstand severe storms and floods. Resourcefulness is the ability to skillfully prepare for, respond to, and manage a crisis or disruption as it unfolds. This includes identifying courses of actions, prioritizing them to control and mitigate damage. Rapid recovery is the ability to return to normal operations as quickly and efficiently as possible after a disruption. It includes contingency plans, emergency operations, and means to get the right people and resources to the right places. And finally, redundancy means that there are backup resources to support the originals in case of failure. Equitable resilience brings together the strategies for resilient design, accounting for the social distribution of the stresses and responses in the event of a disruption. This challenge specifically asks for making equity a central focus of the proposed solution, which means when designing for resilience, you must understand the vulnerability of various populations and communities and propose solution for equity and resilience cohesively. Equity should not be an afterthought or a box to check. Strategies for improving resilience of existing buildings and new construction include all aspects of the building, its structure, enclosure, energy systems, operations, and building use. These include strategies for disaster preparedness, mitigation, and recovery, and may focus on certain hazards depending on the prevalent risks. They may include passive strategies for maintaining survivable temperatures and conserve resources during prolonged periods of loss of power, heat, or water. The grid interactive efficient buildings is an emerging technology that employs strategies for energy efficiencies, renewable energy, energy storage, and load flexibility technologies to reduce the energy needs and peak power demand through smart controls. On the non-technical sides, there are building energy codes and standards which also contribute to improving the resilience of building and communities. Buildings built to these codes and standards are able to maintain survivable temperatures for longer period of times. They require less energy, allowing alternative power sources during power outage to go further to sustain people who are sheltering in place or trying to perform critical job functions. More efficient heating and cooling equipment also means less power on the power grid and more reliable grid infrastructure. Quite recently, the US Green Building Council's LEED rating system has incorporated pilot credits for the resiliency in new construction. These credits encourage the assessment, planning, and mitigation of the risks of disasters for a project, as well as considerations for passive survivability and backup power. Community-level strategies may require a multi-pronged approach using a combination of mandatory upgrades, incentive programs, funding mechanisms, and education or outreach programs to develop more resilient building stock and infrastructure. These may include smaller or more incremental strategies to gradually improve resilience, or larger scale coordinated programs to respond to critical deficiencies. Depending on the hazards, these strategies may include redefined functions of buildings and creating community facilities or resilience hubs that can serve during emergencies or interruptions to services. In this challenge, the strategies for achieving resiliency at a building or community scale must be conceptualized along with considerations for equity. The following 2 slides contain links to suggested additional resources pertaining to all topics discussed in this presentation. Please refer to the jumpintostem.org website for all challenge-related information. We hope that this presentation has been helpful at introducing this broad challenge topic and has generated and sparked interest in potential innovative solutions. Thank you, and good luck to all.